Hello there, math fans. Continuing our short little intro to working in 3D. Watch my previous video about how we work with distance. And this one I want to talk about this idea of corresponding point. Students often get confused by questions of the following sort. They'll say, you're given some point, let's just call it P to label it. Sometimes we use this notation. We call this 2, 3, 4. And then we ask you, how far is that point to other things? Now, at this point, we've already given you the distance formula, but how do you find the other point, whatever it is? If I'm calling this point, one of the points, 2, 3, 4, how do you find the corresponding point? And oftentimes students will try to look up formulas because the question will say, how far is it from this point to the XY plane? And students go, uh-oh, I need the distance from a point to a plane. Dr. Lovelace is a jerk. He never gave me that formula. So they look it up online. They find this complicated formula. They send me an email and say, can I use this formula? And I think there's a way easier way. Can you just think of the other point? And so the goal of these questions is not to look up some formula. It's just to find what is the point. They're telling you a corresponding point. And then there's a later question that says, well, how far is it to the y-axis? And it's the same idea. All of these questions are just trying to get you to think in 3D. Now, I know that scares people, but it's actually super easy. I talk to students and I say, well, what does it mean to be a point on the XY plane? What is the condition? And when you're in an uncomfortable place, like you're in 3D for the first time, you should think in terms of conditions. A lot of people have sort of memorized things in 2D without thinking in terms of conditions. They don't know if I say y equals 0, what that means. So let's think about what it means to be standing on the ground. It means z is 0. Similarly, what does it mean to be standing on the y-axis? If you're on the y-axis, that means you're not up and you're not down. This is 0. If you're standing on the y-axis, it means you're not to the left or to the right. It means this is 0. These are things you automatically know from these names. So it's not as hard to figure out the corresponding point because you already know some of its coordinates. So I always jokingly say you don't have to think very hard. You have to think about what does it mean to be on the XY plane, and then what does it mean to be as close as possible to the given point. And that's not too hard either. What numbers here would be as close as possible to 2 and 3? It's ridiculous when you sort of say it. 2 and 3. What number here would be as close as possible to 3? 3. That's it. That's the corresponding point method. And then you can compute the distance to your delight. Meaning, if you want to know the distance to the XY plane, you find the distance between these 2 points. You plug them in. Now, some of that is overkill. So many students go, couldn't I have just reasoned it out? Absolutely. But if you forget, you can go to the corresponding point. The moment you write this down, you realize it's really silly because it's 0 plus 0 plus 4 squared square root. It's 4. Oh, I should have known it was only 4 units. You say, well, I couldn't see that, Dr. Lovelace. You're covering it up. Oh, come on. There's that 4. All right. So similarly, if you wanted to know the distance from here to the y-axis, use these 2 points. All of it can be done with the distance formula, but that's not really what I want to talk about. I want to talk about visualizing now. Okay, so what about corresponding points? So here is the point 2, 3, 4. I've plotted it here. I made it so I can move them around, but let's put it back to 2, 3, 4. There's 2, 3, 4 over 2. Okay, so let's walk straight over to the coordinate planes. There you go. You should see those. This is just understanding how things work in 3D. And historically, I didn't like giving these pictures because I wanted students to practice visualizing. So don't assume you have to have a 3D grapher to understand the fact that what that point means. All right? So that's that idea of, so if I want to go straight down, that's that. What can I say about that point that's on the ground? Z is 0 and the X and Y are the same. So that point is 2, 3, 0 and it's 4 units up. The same would be true about the other coordinate planes. Okay, the trickier one. What if I wanted to go straight to an axis? What's that going to look like? And I like making these visuals, so that's what it... There we go. Whoa, that looks weird. It's kind of fun. But you can see if I go straight over, it's now a 2D problem. And so I'm going to need a 2D formula, but it's not as complicated as you think. It's just straight over. So if you understand the distance formula, those are not bad, but you really just need the corresponding point. What's the corresponding point that's on the z-axis, for example? It's 0, 0, 4. We got it. What's the corresponding point on the x-axis? It would have the same x-coordinate, which was 2, and then 0, 0. What's the corresponding point on the y-axis? It's the same y-coordinate, 3, and the other coordinates are 0. So if you wanted any of those distances, for example, let's say we wanted the green distance, which is the one I have here. It would be the distance from this point to this point. And we have a distance formula, so we don't have to do anything clever. We don't have to ask AI for some formula, which it'll give us a really complicated formula, which will give us absolutely no understanding of what's going on. I'm trying to get you to think so you can think through a problem. And this would be 4 plus 0 plus 16. It's the square root of 20, which isn't a nice number. You don't even have to rationalize in this class, but it's 2 root 5 if you want to be pretty. That's that green distance. So the goal here is just to get you to think in 3D. And whenever you're thinking about distances between things, if you can find the corresponding points that are closest together, then you can do this problem. All right, I hope you found that interesting.